Dear friends, welcome to my next video session. So in this session I am going to discuss about the multiple pointers. So in my previous video I have discussed about the pointers, what is a pointer, and how through pointers how the contents of variable can be indirectly accessed using indirection operator. What is meant by address operator, that all we have discussed. So we shall focus on multiple pointers. So here single variable can be accessed using multiple pointers. So in my previous video we have accessed the variable through only single pointer. So instead of one pointer, so we can declare more than one pointer to the same variable. So through those multiple pointers we can access the contents of a single variable. Okay. So here the multiple pointers have to be declared. So we need to declare multiple pointers, and all those pointers should be initialized to a common variable or a single variable. So means for a particular variable all the pointers are initialized. Okay. So for example in the below program, so we can discuss how multiple pointers are initialized to a single variable. So we use pointers star p1, star p2 and star p3, that is p1, p2, p3 are three pointer variables which are used to access the value of a single variable called num. So this is what discussed in the following program. So here you can observe the program that hash include stdio.h, it is a preprocessor directive, hash include ponia.h is a preprocessor directive, void main. So here we have declared a single variable called num. So num is called the variable, right? Num is called the variable of type data type integer. So we have discussed one pointer variable called p1. See, star p1. Star p1 is a pointer variable. Star p2 is a pointer variable. So you can observe that star p2 is a pointer variable. P2 is also a pointer variable of data type integer. And here we have pointer variable 3, that is p3. P3 is also a pointer variable pointing to the variable num. Means only single variable num is declared of type integer, and three pointer variables are declared p1, p2 and p3. Okay. So now we can observe that one pointer variable, a single variable, can be accessed using multiple pointers. This is what we can observe here. See, num assigned a value 1004, means normal variable assigned a value 1004. p1 assigned a value ampersand num, means p1 is initialized to same variable number. p2 is assigned a value ampersand number, means p2 is also initialized to same variable, and p3 assigned a value ampersand number. p3 is also initialized to a normal variable. So p1 is initialized to number, then p2 is initialized to the same number, then p3 is also initialized to the same number, means all the variables are pointing to the same variable number. Okay. So then we can print the value of number using respect to printf statement. So let us trace the program and see what will happen. Okay. So declaration num. So here we have declared variable memory is reserved for num. So here we have declared variable num. Okay. Num is declared. Star p1 means p1 is a pointer variable declared here. P1 is a pointer variable. So the starting address of num, assume that it is 1000. 1000 is the starting address. So p1 is a pointer variable. Star p1 is a pointer variable. So p1 is a pointer variable whose address is 3000. p2 is a pointer variable. See, p2 is a pointer variable to data type integer. So whose starting address is 4000. Integer star p3. So p3 is also a pointer variable whose address is 5000. Starting address is 5000. Now see, num assigned a value 1004. So already num. So using assignment statement, num assigned a value 1004. The content of num will be 1004. Then this statement is executed. Then p1 assigned a value ampersand number. So this p1 assigned a value ampersand number means address of num. So what is address of num? So this is what num. What is its address? 1000. So content of p1 is 1000. Okay. Then p2 assigned a value ampersand number. So content of p2 is also address of num. What is address of num? Once again 1000. Then p3 assigned a value ampersand number. Address the NUM content is 1004. P1 is 1000, P2 is 1000, P3 is 1000 because P1, P2, P3 hold address of NUM. Address of NUM is 1000. So this is what the status of memory. So now see, first printf statement, what it will do, printf backslash and in new line, the value of num is equal to %d. So in place of %d, now what will be displayed in place of %d? In place of this %d, content of NUM. So what is this content of NUM? What is the content of NUM here? 1004. So that's why you can observe here, this is the value of NUM is equal to 1004. So then the value of NUM, next second statement, printf means in new line, the value of NUM is equal to $d. So in place of %d, what will be printed? *P1. *P1 means content of P1. What is content of P1? 1000. What is content of 1000? 1004. So observe here, *P1 means content of P1. So what is content of P1? Content of P1 is, you can observe here, content of P1 is 1000. So content of 1000. So what is the content of 1000? 1004. So that's why you will get 1004. Next, third printf statement. See, the value of NUM is equal to So in place of %d, so you'll get in place of %d, you'll get *P2. *P2 means what? Content of P2. What is P2? 1000. What is its content? Its content, 1000 content is 1004. So that's why you will get 1004. Next, printf backslash and in new line, the value of NUM is equal to. So value of NUM is equal to what? %d. *P3. So in place of %d, *P3. What is P3? 1000. Its content. What is 1000's content? *P3 means content of P3. Content of P3 is 1000. What is content of 1000? 1004. So this way 1004 is displayed. So this is how, see, value of NUM 1004 is displayed directly and indirectly through pointers P1, P2, P3. So here we can say that the variable has multiple pointers. Variable NUM has multiple pointers. So that is what the concept of multiple pointers. All the pointers P1, P2, P3. So they are pointing to the same variable NUM. So that's why we can say that. See, you can observe here, all having the same pointer NUM, ampersand NUM, ampersand NUM, ampersand NUM. P1, P2, P3 pointer variables. All pointer variables are assigned to pointing to the same variable NUM. Means the address of NUM is stored in all variables P1, P2, P3. So this is what multiple pointers. So now we can see difference between a pointer variable and a normal variable. So now we have a concept that variable and pointer variable. So what is the difference between pointer variable and normal variable? So a pointer variable holds what? Address. That we have seen, pointer variable holds address. Always it holds address of memory location. Right? That's a pointer variable holds address of a memory location. Whereas a normal variable holds just data. So to store the data we use normal variable. To store the address of normal variables we always use pointer variables. So what is the general format of pointer variables? The general format of declaring a pointer is what? So this is what? Data type star pointer name semicolon. So here star should be there. So that is what very important. Star should be there. Okay. This one. Star should be there. Star pointer name. Whereas the data type, the general form of normal variable is what? Just the data type and variable name terminated by semicolon. General format for initializing a pointer variable. How do we initialize a pointer variable? So we initialize a pointer variable using this syntax. Pointer name, assigned a value, variable, terminated by semicolon here, right? Semicolon. Okay. So pointer variable name, just like in my previous case, P1, assigned a value ampersand NUM. So here, pointer name, assigned a value ampersand variable name, semicolon. So whereas the general format for initialization of normal variable, how the normal variables are initialized? Just variable name, assigned a value. Okay. So that is what you have to observe. And here a dereferencing pointer, not variable, dereferencing pointer is essential to access the data for pointer variables. whereas for normal variable dereferencing operator is not required. So here dereferencing operator is required. So what is dereferencing operator? Dereferencing operator is star, no, star. So this star is required to access the data here. So here star is not required to access the data. Star is not required. So this is called dereferencing operator. So this dereferencing operator is not required to access the data. Here this is not required. Without dereferencing operator, you can access the data. Okay. So also you can say here we will write P1 assigned a value. Okay. Star NUM we can write semicolon. So this is called dereferencing pointers are required. Whereas to access the normal variable, how do we access the normal variable? So we access the normal variable. Sorry. Okay. To access the normal variable, so this is not required. So we require dereferencing operator, right? So for example, y assigned a value star p we can write star p, or simply you can write y assigned a value star p. P is a pointer, then y assigned a value star p means content of p. So this dereferencing operator is required. Whereas to access a normal variable, we say y assigned a value num semicolon. Here just normal variable. You can observe here dereferencing operator is not required. So this is what the difference between pointer variable and a normal variable. Okay.